Let's start with number 1 on the exam for review. To determine this one, I'm looking at the top left-hand corner of your exam 4 handout for finding a critical T or a critical Z. The first thing under critical Z I see is that it says used for proportions and mean when standard deviation is known. Well, if I go right here, I see that my standard deviation for the population is known. I also see that the population appears to be normally distributed. So with that information, I can go to StatCrunch, and I'm pulling this up on a separate device because my technology isn't talking to one another today. So I'm going to go to Stat, Calc, and I'm going to go down to the normal calculator. I'm going to leave the mean at 0 and the standard deviation at 1. I don't know if I told you yes or not, but go to between. And then my confidence level is 92%, so I'm going to enter 0.92 in the far right box at the bottom and click compute. So when I do that, and this is kind of what my screen looks like, I went to Stat, calculator, normal, mean was 0. We left standard deviation at 1. Because we chose between, it looks like this. And in the very back, I entered my 0.92 from the confidence level in the problem. When I click compute, StatCrunch says, oh, there you go. The left z-score is negative 1.75 and some change. And the right critical z is 1.75 and some change. Always choose the positive one when you're looking for a critical z. So this is the one we're going to go with. The second one is a little bit different. We're not going to go through all of these. This one does say we have a confidence level of 94%. Our N value is 8. Our sigma, so the population standard deviation, is known. But then there's this. The population appears to be very skewed. Now, if you look at the first page of section 8.2 in your notes, for choosing between student T and normal Z, you look at the conditions, and it says, since we do know that sigma is known, it says we have to have a normally distributed population. Well, it's not normally distributed. It says it's skewed. And that sigma is known. Well, yes, we know sigma, but our population appears to be skewed, and that means we cannot run normal Z. We cannot run student T because we know sigma. So in this case, we don't get to run either one of them. Looking at question 3 very quickly, I see that sigma is unknown and the population appears to be normally distributed. The chart at the top of the first page of section 8.2 in your notes says when sigma is unknown, but the population is normally distributed, you can use student T. Same process that we used up at the first one for calculating the critical values, except instead of normal, you go to student T. So we go to stat. Calculator. Go down to T. We're still going to use between. Now remember, you have to use the degrees of freedom. Degrees of freedom is your sample size minus 1. So our degrees of freedom is going to be 6. And we want a confidence level of 0.96 in that far right blank. So this is sort of what my screen looks like. I have the degrees of freedom. And then it tells me my two T values are negative 2.6 and some change and 2.6 and some change. So that means we need that guy. Similar story for 4, 5. You're still using the chart at the top of 8.2. And you are using the similar steps that are on the top of your exam 4 handout. Now let's take a look at some confidence intervals with number 6. Given the interval estimate for the mean, the point estimate for the mean is, and the margin of error is the EBM. So here we go. I told you guys a long time ago that if you asked me a question, my first response was going to be, did you draw the picture? Well, here's my question right here if you're stuck on this one. Did you draw the picture? So we have a lower bound or a lower limit of 8 and an upper limit of 11.8. And our mean that we're looking for is going to be somewhere in the middle. Well, we need to find the exact middle. And again, on your exam 4 handout, in the middle of the page on the left, you have a rectangle that says constructing confidence intervals for the mean. So the mean means we need to find the middle of that interval. So we're going to find the average. So I'm going to pull up a calculator. You won't be able to see it, but it really does exist. So I'm going to plug that into Desmos. This tells me that my average is 9.9. That is my point estimate for the mean. Now we need to find, sorry, I should be calling this X bar. X bar is our estimate for the mean. Now we need to find the margin of error. If you again go look at your formula, It tells you that the distance from X bar to 8 is the EBM. So to calculate the EBM, I'm going to do X bar minus that lower bound. So 9.9 minus 8 gives me an EBM of 1.9. 7 is very, very similar to what we just looked at. We have a confidence interval that P is between 14.3% and 29.7%. We just need to change the form it's written in. That means we need to find P hat and the EBP. Now notice we don't have N, we don't have a sample size, we don't have number of successes, we don't have a critical Z value. That means we need to draw the picture. I have a lower bound of 14.3%. I've got an upper bound of 29.7. I need to find the middle. The middle is going to be the average of the bounds, so I'm going to average 29.7 and 14.3. To go use my magical off-screen calculator. The average of 29.7 and 14.3 divided by 2 is 22, which is super awesome. They've thrown us a bone because we don't have to worry about rounding. So our P hat is 22%. Now we need to find that EBP. The EBP is the distance between the lower bound and the mean, or the lower bound and P hat. So I'm going to start with P hat and subtract the lower bound. Because I love you, I'm going back to my calculator. And I get 7.7 for my EBP. So when we express the confidence interval in the form P hat plus or minus EBP, we have P hat of 22, and they already have the percent symbol, plus or minus 7.7%. Eight's a little different because they give you more information to work with. So let's go through the word problem and find the important parts. You measure 47 dogs' weights. This, to me, sounds like a sample size. You find they have a mean weight. So we have a mean, and this is a sample of 47 dogs. So this is, this is X bar. Assume the population standard deviation. So right here, population standard deviation. They are screaming to you that that is sigma. Based on this, find the margin of error to construct a 95% confidence level. So our CL is going to be 0.95. Now, I do believe you have steps for this on your exam 4 handout as well. On the left side, the middle box, we are dealing with means. So we're going to look in the box that says constructing confidence intervals for the means. If you look down at the bottom, it tells you exactly how to do this in StatCrunch. So I am going to go to Stat, Z-Stats, because I know sigma. We're going to do one sample, and we're going to do with summary. So I'm going to switch over to my Phantom StatCrunch device. And I'm going to take my own advice. I'm going to go to Stat and Calculators. I'm sorry, not Calculators, Stat and then Z-Stats. One sample with summary. So we had a sample mean of 38. The standard deviation of 13.7. And a sample size of 47. Now we're not doing hypothesis testing, we're constructing a confidence interval, so make sure you select confidence interval for mu. It's already set to 0.95, so I am going to compute. So I find out that I have a lower limit or a lower bound of 34, not 3.4, 0.083, and an upper bound of 41.92. I did 3 decimal places, so 917. And we don't want the upper bound and the lower bound, we want the EBM. So I am going to go through and I'm going to find my mean. I'm going to average the two. Wait, they told me X bar. X bar is 38. So my EBM is the distance between 38 and the lower bound. (38) minus 34.08. So we should have an EBM of 3.92 ounces. Now, I jumped into that very quickly as far as the method. I went straight to StatCrunch. It might have been easier. It would have been shorter, that's for sure, if I had pulled off the EBM formula. Whoops. I can read the formula, I just can't write it. So you can calculate your EBM that way as well, especially since I think you should already have the critical or the confidence interval number for 0.95 on your formula chart, but either way should get you there. We can talk briefly about 9. We probably won't go through the whole problem. Isa wants to estimate the average number of hours. So right here, we know we're talking about means. We have a random sample of 42. That tells me my sample size. The sample average, so this is X bar. Based on previous evidence, she believes the population standard deviation is approximately 1. So they are screaming to you that sigma is equal to 1. Since we know sigma, we're using normal Z. And if it asks, I can't do the drop-down menu right here because I had to work off of a PDF. If it asks, it's the normal Z for the means. We're supposed to use the findings to construct a 99% confidence interval for the appropriate population parameter. I believe that on your exam 4 handout on the right hand side at the top corner, you have the decimal for this. That means you're going to use 2.575 for your critical Z. So you can either plug it in the formula and find your EBM and then work off of that. Or you can use the steps for StatCrunch from the last one. 10 has parts. I'll have to make a note of that and go back to it later because I can't get to all of those parts with a PDF. Bear with me, I'm putting it on my to-do list. Let's see what it says. Laverne wants to estimate the average number of patients. So right there we know we're dealing with averages. Who experience surgical complications per day across a large hospital network. The population is normally distributed. That's good news. We have a random sample of 25 days. We find the sample average, so this is X bar, with a standard deviation of 1.9 patients. Y'all, this is coming in the same section as the sample data, so this is the sample standard deviation. Now, because we have an approximately normal distribution, and we know the sample standard deviation, this is student T. For the means. We want to use Laverne's findings to construct a 95% confidence level. So we need a critical T. To calculate the critical T, you have steps for that at the top left side of your exam 4 handout. You go to Stat, Calculators, NT. Remember to use your degrees of freedom. That's N-1. Leave the mean and the standard deviation at 1. And make sure you use between. That should calculate your critical T. The other option, which might be shorter, is to go straight to StatCrunch because you do have all of the information, and do stat, T-stats, one sample with summary, and plug in all your stuff. The difference with 12 is that right off the bat, they tell you percent, and we talked about how the P in percent was a clue that you are going to use proportions. So that means you are now on your exam handout in the bottom left-hand corner with those formulas and those StatCrunch steps. Because you're going to need a value for P hat, no, I don't think you will. When you plug this into StatCrunch, it asks you for number of successes and number of trials or sample sizes. So you have number of successes, 100 is your sample size. I think that's all it asks you for. Let me double check. Number of successes was 75. Number of observations was 100. And we want a confidence interval with a 99% confidence level. And so they give you a lower limit, we want 3 decimal places, of 0.638. And an upper limit of 0.862. Okay, I'm gonna stop there because I need to go pick up my kid, but I will do some more in another video.